So, what classes do we have here? Dealer, deck, and card. Exactly. That was pretty easy. So let's add dealer, deck, card. That was probably not so surprising. We also find these in the domain model, and we should of course use the same names from the domain model if we have similar concepts, so that we minimize this semantic gap from ID requirements, domain to design implementation. So the next question then is, what kind of relationships will we have, and between what objects or classes will it be? So in this case we have objects, and we can see that we have messages that goes from one type of object to another type of object. For example, the dealer creates the deck. So we send a message. In the implementation, this will be a function call, or what you call it in your language. It will be new or something like that. And this means that we have some kind of relationship between dealer and deck. But we now need to decide. We have 4 kinds of relationships. We have the interface realization, generalization, specialization, dependency, or association. Which one should we choose? Well, we can probably see that, well, deck is not an interface, so it won't be a realization. We don't really want to inherit from deck, because dealer is not a type of deck. So not generalization, specialization. So we're left with 2, and that is association or dependency. And just looking at this diagram, the dependency is probably the choice. Because what we can see here is that, well, yes, we create the deck. We could store that in a local variable and then shuffle that local variable and then throw it away. So dealer deck could be a dependency. However, looking a little bit further for the requirements and knowing the game and the domain, we know that, well, the dealer needs to take cards from the deck when we start the game later on. So we need to store the deck in the dealer. So in this case, we will do an association instead. So dealer and deck, association. Where should the arrow head be? On the deck side of things? Exactly. Dealer is associated to the deck. And we know from the domain model and our limitations that, well, we will just be dealing with one deck. So I won't be doing any multiplicity there, so because it's clearly stated. But we should add a role name. And, well, it won't get more fun than this in this case, I think. You should always strive for better role names than this, but I will just call it m_deck, at least for now. Not the best, especially if we would have more associations between dealer and deck. You remember the person and the car example that we did? You could have, well, we need to know that the car has a driver and it has passengers. So we should not just say person 1 and person 2, 3, 4, 5, but rather passenger, owner, driver, and so on. So try to find the good roles. Maybe handle deck or deck to handle or something like that. But yeah, I think m_deck in this case will suffice. So the next thing we can take a look at is, well, when we create the deck, we send similar messages to the card type. We create something, so we need to have a relationship between deck and card class. And later on, we will also need to use these cards when we do the shuffling of the cards. So we need to remember this collection of cards between two function calls. So in this case, it's quite obvious that we need an association. Because if we just create the cards, add them, and then kind of like throw them away, we don't have any cards to shuffle. So yet again, an association between deck and card. This time, we could have many cards. When we create things, there will be 52, just as we stated in the domain model. However, looking at the requirements, we will probably pick cards from the deck and give them to both the dealer and the player. So the number of cards in the deck could vary. And also exactly at the actual startup here, there will be 0 cards in the deck. In the constructor, it will be filled, but when we start out, it will be 0. So therefore, I opt for the star here, or the what that looks like. And the role name, m_cards. Any questions on this part? No? It's clear? So with the relationship between dealer and deck, we had to think a little bit more. We could rule out realization and generalization quite quickly, but should we select an association or a dependency? And we need to think a little bit more about the future and realize that, well, we need to have the deck shuffled and ready for dealing later on. Between deck and card, the association was actually given the sequence diagram because, well, we need to know the cards so that we can shuffle them later on. Enough designing. Let's do some implementation. So we will be creating the dealer, deck, and card classes. Which one should we start with? Dealer. Why? It's first, yeah. But when we do the dealer, it will need a deck to compile, and the deck will need a card to compile. But card is self-contained, so to speak. We don't have any dependencies going out from card right now, at least. This means that we can actually implement this one without having the deck. And we can later implement the deck when we have the card, and we need the deck to implement the dealer. So you can look at a diagram like this and find at least an idea of an order for things. This also is a little bit dependent on you if you would like to go top down or bottom up. Thinking about reuse also, you can see that, well, the card class should be quite easy to reuse because it has no dependencies. So this one you can take really easily. If you were to take the dealer, well, then you need to change the code to remove the deck or bring the deck along. And if you bring the deck along, you need to bring the cards along. So suddenly you have a little bit of a chain of things to think about when you reuse. So, okay, let's start with the card class then, just to make things fun. The second question is, okay, where should we put this card class? Should it be in the model, the view, or the controller? Is it about the user interface? No, not really. Is it about interaction? No, not really. It does not handle a use case, for example. So it should be in the model. And thinking about it, all these types should be in the model. They are kind of like the core of the domain. They are also present in the domain model. This is often a sure telltale sign that it should be in the model. In the user interface, we will probably add things like, in the dice game, console, player, stuff like that maybe. So let's do it. Card. Model, add new item. Card. So the constructor. If you remember back, we should send in the color and the value. It's not a good idea to have cards that do not have a color and a value. But what kind of types for the arguments should we use? Yes. Here we should have something like a color, a value. But what types should it be? Any idea? String. Yeah. Int could be it also. But I think that we have got one good answer here in the chat, and that is enumerators. Strings and integers are good for strings and integers, but a color, it's not really an integer or a string. It's like hearts, clubs, diamonds, or spades. Can only have 4 possible values for the color in a card. So why use a type that allows you to assign it many, many, many more values? So by using the language, we should restrict possible errors and possible mistakes and misunderstandings as much as possible. So enumerators, any good language has them. PHP do not have enumerators, so you can make your own conclusion. Color. Hearts, spades, I usually do that last. Diamonds. And as a convention, I actually always add a count here. In some languages, you can iterate over the values in an enumeration. In other languages, you can't. For example, in C++, you need to know how many values there are because you can't iterate over the type, so to speak. So I usually add this, but this is more or less just me. It will facilitate for us a little bit later on also, but well, it's a convention that I use. Value, and we have 2, 3, 4, 5, 6, 7, 8. And color, value. Thank you. So we will also make these public. So if we were good designers, we would probably have thought about this, especially as we had this loop condition. We need to loop all over all colors and values. So we had a little bit of an open issue there in our design. But sometimes you also see things when you sit down and implement, and okay, I'm going to write this constructor now, and we have arguments to it, but okay, what types do they have? In this case, we settled on enumerations as a good implementation and design for this. So we added the color and value in the card, and we can now use these. I think that this is maybe pretty much it for now. This is what we need. So we should not speculate into the future and add a lot of functionality here, even though we can probably see that we need it. But the card is done for now. Let's move on to the deck. So first we implement the association. Now we need to take another decision. How am I to store the cards? The design just said, okay, you are supposed to store many cards. It is actually not that important in this case what type of collection we use. I selected to use the list. If it's really important, you can hint it in the design by using a constraint. So we can show that a little bit later on. So anyway, what should happen here now? Well, going back to the sequence diagram is okay. We create the deck, so we're in the constructor here. So what you should do here is to loop for every color and value, create a card with the color and value, and add it. So okay, let's do that then. So we create two loops. We loop over the color and the values. We do this by some casting. Not the prettiest thing maybe, but you can do it in other ways, but then it becomes quite C# specific. Other languages have probably other ways to do this. Java probably has. C++ use kind of like this way. And this is maybe the most language neutral way of doing this, so I opted for that. But it will require some casting, but and maybe that's not so pretty. Add, so something like that. We need to implement add also. Something like that. Questions on this implementation? Do you realize what we have missed? Need to create that one first. And finally, we add the dealer. And that implementation is not that hard. So we implement the association here. Common, what is it called in C#? Property? Yeah, maybe property. Member variable in some other languages and attribute in UML. We need a way to test run this also, so we will just be creating a dealer here. So can we get things to run? Yes, we can. So the next step is also to check if, well, did we get the result we wanted? And let's just print something right now, and we will see if something happens. Yeah, we got a bunch of cards at least. Would probably be interesting to know that we have created a sequence of cards and get color. No, get value. So we got a number of cards ending with ace of spades, of course. And we got from 2 of hearts to ace of hearts, 2 of clubs, to ace of clubs, 2 of diamonds, to ace of diamonds, 2 of spades, to ace of spades. That seems to be working. And the next step is to add this shuffle operation. So the dealer, after creating the deck, should shuffle the deck. Shuffle it. So we will implement this now. So basically what we will be doing is to remove a card from a random position in the deck and put it in the first place again, to shuffle it. And this is not something that we have specified in the design on how to do this, so we are free to do this in any way we can during implementation. And well, So this is just one way of doing it. Maybe there are some shuffle operation or something like that on the collection we could use, but I don't know that. So card. So, yeah, just generate a random number between 0 and the number of cards in the deck. Get that card, remove it, and add it using the add operation. This also means that in this case we should get a printout of the shuffled deck, which is good, so we can see that it was actually shuffled. No. Ah, thank you. Damaged by C++, I think. So, oh, things worked. So first we get the cards in order. Clubs, 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 diamonds, diamond, diamond, spades, spades, spades. And then we get some kind of a mixed order here. So diamonds, spades, clubs, diamonds, diamonds, spades, diamonds, spades, 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 diamonds, diamonds, hearts, yeah, and so on and so forth. And, well, you could, of course, argue that things are not completely random, but I think they will suffice for our need at least. One very, very stupid thing we did is this one for testing purposes. You can't do this. It violates the architecture, so this is really, really bad, and one must remember to remove this. And this is something that is easily, it's really, really easy to add. Well, I'm just adding some debug printouts or something like that when debugging or developing for testing purposes, and then you forget or are too rushed to remove them. And you add these little dependencies more and more and more, and that is not a good thing because the quality then deteriorates. And, well, a new programmer comes in and he sees this. So, but, oh, so it's okay to echo stuff in the console then. Okay, I can do that also. So make sure you don't do this, and make sure you keep track of it, maybe with a comment if you are supposed to keep it for versioning or something like that. I think we should just remove it. So something like this is actually the first part of the requirement. We now have a dealer, we now have a deck, we now have a shuffled deck with cards, and we have colors and values for the cards, and we decided to use enumerations. So we are good to go, and we will go to the next part of the requirement, and that was to display the some kind of welcome message or rules on how to play. Where should we do that? in a controller, in a view. I would like to say in a view. It has something to do with the user interface. And of course, a controller could be added to prompt, okay, now it's time to display the welcome message or the game rules or whatnot. But I think it will suffice if we just do a simple view class here for now. Let's stick with our convention from the dice game. I think that was pretty good. And call it console. And so we just do this present instructions. And we will just keep it simple, so something like that. And let's create a view. So I think that's about it for the first requirement. We have actually done that. You can't play the game yet, but the first requirement is done. Any questions on the implementation or the design work? I will post this on GitHub, of course. We could maybe add the add operation here to show that, well, in this shuffle, we actually use add once more. You can write a little note about, okay, shuffle the cards randomly or something like that as a design note for those who are to implement. More importantly, maybe we should add the enumerations here in our class diagram, because those are not present right now. And I think we will do that using visual paradigm. I think that will work out in a good way. So, bloop. It imports these from the domain model where we have the same classes actually. So that's a little bit cool. But we have an enumeration. Color. value. And you could also write the actual values here for the color spades and diamonds and clubs and hearts, and for the values also, if you would like to. So let's add the associations to deck. Deck. Associations to card. And we will show containment here. And I hope they have this in, yeah. So to show that, well, these two types, the value and color enumerations, are actually part of the card class, we use this little notation here, a little line, and at the container we have a plus sign. And also, if we are really, really picky here, we know that the deck uses actually value and color, because it loops over all the colors and all the values, and it casts, and it uses those types. Not a member variable, but a dependency. So if we are really, really picky, we should add these also. So something like that. And you could also add association to a value and a color here. However, I think it's, in this case, probably better to use attribute types here. But this is, as we saw with the data types in domain modeling, it is more of an exception to the rule that if you have a member variable, you should use an association. But in this case, I don't think it will make the design any more visually comprehensive than to add types here instead. So let's do that. Did I do the wrong one? Yeah, I did. So we can now see the types here instead. So basically what we did was we did a little bit of designing. We thought about the requirements and how they would be realized by the design. We did a sequence diagram. Using this sequence diagram, we created a class diagram. Using the class diagram, we did some implementation. We realized that we had forgotten something or had not decided, for example, on the values and the color of the card. And so we decided to use enumerations. We did our implementation, tested it a little bit, then went back to the class diagram and updated it. And we could also go back to the sequence diagram and update the shuffle operation there. And basically, this is how you should work in Workshop 2 also. do a little bit of design, do a little bit of coding and testing, update your design. Don't spend hours upon hours designing. Don't spend hours upon hours coding. Do them intertwined. And what you start with is more or less up to you. If you think you can start coding right away, then do so. And maybe towards the end, this is a better option. Towards the beginning, maybe you should spend a little bit more on designing before coding. And you can switch that when you feel more secure in your design. Questions? No? We didn't get into the patterns that we actually used when doing this design. More specifically, we used the creator pattern. So we have a few minutes here, so we can take a quick look at it. Since our problem was about creating objects, we can use the Grasp creator pattern, because that is just about, okay, what class should create objects of another type? And that is what we did. And we have some 4 rules here to take a look at. And we should assign the responsibility to create an object of type A to class B if B objects contains A objects. And we could see that, well, the deck contains the cards from our domain model. So it's a good idea to let the deck actually create the cards. The B objects have the information needed to create A objects. That was also something that was present in our design, to let the deck create the cards, because we need to know what cards were in the deck to know what cards to create. We cannot create duplicate cards. So if, for example, we would have let the dealer create the cards and add them to the deck, this is possibly a good solution. Then we would probably need to make sure that, well, the dealer should not be able to add duplicates. So other options are B objects records A objects in some way, or B objects closely use A objects. And maybe this is the instance of the dealer and the deck. Looking at the requirements, well, the dealer will physically hold the deck for when playing blackjack. He will deal cards from the deck. He will put cards back into the deck, and so on and so forth. He will shuffle the deck. So maybe it's a natural thing to let the dealer object create card objects. So this is basically how the grasp patterns work. That we have a small problem, and sometimes the solution is obvious, or you use that solution many times. But when you run into problems in your implementation or your design, it is often because you have violated one of these basic principles. But we will be talking more about the grasp patterns throughout the implementation of the dice game. I hope to be able to do this for this week. Maybe we will also get into the Gang of 4 patterns towards the end. You never know. Questions? Yeah? No. In this course, it's not about testing and more rigorous testing, but rather that you should test your application and test that, okay, the unit testing, so to speak, that you as a developer do. I don't mean that you should write a big fat test specification. But you should, of course, make sure your application works. And this often requires some form of structured way of testing things and not just hack away. So if you prefer to write down something, okay, I should test these things at least, and make a short checklist, that is fine by me. But how you do that is not part of this course, and you can do that how you want to do it. But your application should work for at least some basic usage. I also think for the workshop we have some instructions regarding this. Simple error handling, for example, the application should not crash, but it does not need to be user-friendly. So you don't need to specify really good error messages or make sure that, okay, if you typed an empty boat name, it is fine to just go back to the main menu or whatnot. You don't need to add really user-friendly error messages and stuff like that. But also, it should be well-tested, runnable version of the application. So don't give crap to your fellow students for the peer review, because then you won't get any good feedback. So for the workshop, you need to the runnable version you need to supply, and you need to supply source code and class diagram and sequence diagrams over some of the requirements. So that's about it. But as I said, take a look at this workshop right away. Ask questions on the lectures that we have now, or at least start asking questions at the beginning of next week, so that you don't delay to start the workshop until Monday or Tuesday, because chances are that you won't have time to complete it. All depending on how good of a programmer you are. If this stuff is, well, I know how to handle files and stuff like that, no problem. I know how to debug and I know how to do all these things. Then it can be quite an easy workshop also. So, but my experience is that people will struggle with this. More questions? Final reminder, make sure your portfolios are accessible for the first workshop. If you have them on Google Drive or something like that, make them public or shareable, or how you do that. And make sure you add the peer reviews also if you haven't done that. That's it for me. See you tomorrow, I think. Bye for now.